This meeting is being recorded. Let's go ahead and begin section 1. These are the gas laws. There are 4 laws, which are why you will have 1 homework assignment per night. I don't anticipate you on having any homework over the weekend, but Monday night, Tuesday night, Wednesday night, Thursday night, Friday night, or not Friday night, hopefully not Friday night, is when you'll have these assignments. Okay? So, we're only going to focus on this state of matter. Notice that there is no ASS in gases. It's GASES. There's no ASS. There's no ass in gases. It's the other way around. Got it. There you go. All right. There are 4 gas laws, and they are named after the dead fellas that discovered them. And each of the laws, 3 out of 4 of the laws discuss 2 of the 3 factors, or 2 of the 3 properties that are inherent in gases. And the 3 properties that they discuss are going to be volume, which is going to be measured in either milliliters or liters. And this is simply space occupied. The traffic volume on I-275 at the end of the day is crazy. It's like a parking lot. There's so many cars. The traffic volume on I-275 right now is 10 o'clock. Probably not bad. Everybody's already at work or school. The next is going to be pressure. Pressure is going to be measured in either kilopascals, atmospheres, or millimeters of mercury. Which one is the metric system measurement for pressure? Keep that in mind. Your brain might want to say millimeters of mercury. Millimeters is a measurement of length and distance. Well, this is simply force applied to a surface, or just force applied. This is the pressure a gas generates. When you add more gas to a container, it applies more pressure. Then we have temperature. Temperature is going to need to be measured in Kelvin. So I'm going to need to teach you how to calculate Celsius from Celsius to Kelvin. It's actually very simple. Temperature is just the average kinetic energy. You know, right now it's 75 degrees outside. That's the average kinetic energy of the gas particles in our atmosphere. That means that there are particles that are moving at a temperature faster than 75 and at a temperature cooler than 75. 75 is the average. So today, I'll try to keep it to 1 a day. Today, you are going to learn about Boyle's Law. And hopefully, guys, you will be able to work on these activities in class. I'll give you that opportunity. All right. Robert Boyle came up with this equation, and he described the relationship between, you ready? Pressure and volume of a gas. Pressure and volume. Tomorrow you'll get a different equation with 2 different factors. On Wednesday, you'll get a different equation with 2 different combinations of factors. And then on Thursday, it's going to be all 3 of them bundled up into 1. So, in this whole concept of pressure and volume, temperature is considered a constant, and therefore it is a non-factor. So when I say temperature is constant, that means it is unchanging. It is a non-factor. So you don't need to worry about temperature when it comes to Boyle's Law. Temperature is going to be the same throughout. Pressure and volume are inversely proportional. To be inversely proportional means that whatever happens to one of those factors, the opposite will happen to the other. So that's what that means. To be inversely proportional means whatever happens to one of the factors, the opposite will happen to the other. Okay, so the heck does that mean? I don't get it. Here's an example. Let's say I have a container where there are 2 atmospheres of pressure and it's 6 liters of volume. 2 atmospheres of pressure, 6 liters of volume. What if I told you that the pressure doubled? Jade, what type of math would you say is done when I make the claim that pressure is doubled from 2 to 4 atmospheres? Multiplication by how much? All right, so this is times 2. So Jade, what is the opposite of multiplying by 2? Dividing by 2. So what is 6 divided by 2? 3 liters. That's what I mean by whatever happens to one, the opposite happens to the other. If the pressure is doubled by a factor of 2, that means multiplied by 2, 2 times 4, or 2 times 2 is 4. Then 6 divided by that same number is 3. That's Boyle's law. Whatever you do to one, you do the opposite to the other. They are inversely proportional. So when you see them on a chart, like an XY axis, if this is volume, V for volume, P for pressure, the chart is going to be a downward going slope. This is an inversely proportional rate. So, let's see if you guys can actually make sense of this. I mean, if I just put X and Y axes, that's cool. Great. Sure. Swell. Wonderful. Let's try to make sense of this. Let's go 10, 20, 30, 40. I'm going to zoom in on this. 50, 60, 70, 80. Let's say the pressure is in kilopascals. Then my volume measured in liters, we go 10, 15, 20, 25, 30, 35, 40, 45, 50. Max, I want you to take a look at this curve. According to the y-axis, is pressure going up or down? It's going down. Very good. So, Arshawn, if pressure is going down, what is volume doing? It's going up from 10 to 15 to 20 to 25 to 30. So you just have to look at the graph. As pressure goes down, volume goes up. That's Boyle's law. If I take this tennis ball, Jade, I'm going to crush this tennis ball. What is going to happen to the space within this tennis ball? It will get smaller. It will decrease. So Colby, what is happening to the pressure inside as I make the space smaller? It increases. And it takes more strength by me to try to push it even more and more and more and more. So pressure and volume are inversely proportional. The equation for Boyle's law is as follows. P1 times V1 equals P2 times V2. How many variables are there, Carson? There are 4. 4 variables. P1 and V1 are your initials. They're your initial volume. Initial means what you're starting with. P2 and V2 are new conditions. So it's basically before and after. Initial would be before, and P2 and V2 will be after. So there are 4 variables, everybody. Do you know how many you will actually be given in the word problem? 3. You will be given 3. You just have to find the 4th. And that's where your algebra skills are going to come in. You're thinking, oh, no. You'll be fine. Promise. I don't make promises a lot in here because I know you all have different math skills. You'll be fine. I promise. This is actually the easiest of the 4 equations. So let's do a practice problem, and then I'll let you get a head start on your homework. Practice problem number 1. Okay, here we go. A diver blows a 0.75 liter air bubble 10 meters under water. As it rises to the surface, the pressure goes from 2.25 atmospheres to 1.03 atmospheres. What will be the volume of air in the bubble at surface? Okay. Now, everyone, you're clearly in Chemistry 1 honors, but you have to be able to read above anything else. So this is a Boyle's Law problem. So you know you're going to have P1 times V1 equals P2 times V2. Your first job, and I would dare say your most important job, is to read this problem carefully and correctly identify your 3 knowns and your 1 unknown. Remember, this is a 4-variable problem. P1 is your first variable, V1 is your second, P2 is your third variable, and V2 is your 4th variable. Because there are 4 variables in this problem, you are given 3 of them in the word problem. So what I would like the help from you all is to tell me which numbers in the problem belong to which of those variables, P1, V1, P2, V2. So read the problem, raise your hand when you find it, and I will confirm or deny what you say. Derek?
So for V1, it's 0.75.
That is correct. V1 is 0.75. Now, 0.75 what, Derek?
Liters.
You have to say liters. And what is liters a measurement of? No. Liters is a measurement of volume, so you know, okay, well, at least he didn't say atmospheres. That's good. So he's on the right track, and he is correct. Okay, what's another one? Arshawn?
P2 is 1.03 atmospheres.
P2 is 1.03 atmospheres, and we're missing one more. Kevin?
V1 is 2.25 atmospheres.
Correct. So what variable are we trying to find? We have V1, we have P1, we have P2. We need V2. V2 equals an unknown amount of what will the unit of measurement be? Liters. There we go. I would recommend you guys set up your knowns and unknowns. Some of you really need help organizing your thoughts. If you're one of those people, be honest with yourself and make a list of those knowns and unknowns like I have. So I told you I think you're going to be fine in all this. Actually, let me write this in a different color just to make it look cool. V2 is an unknown amount of liters. All right. So I do really think you're going to be fine here. So the equation is P1 times V1 equals P2 times V2. You are trying to find V2. So algebraically, you want to isolate it. You want to get it by yourself. For all of you algebra whizzes, how can I get V2 by itself? Francis?
Divide both sides by P2.
Say it louder and prouder.
Divide both sides by P2.
You divide both sides by P2. That is correct. And so P2 cancels out on the right. And now if you want to look at your new fancy schmancy setup, P1 times V1 over P2 equals V2. So what you've done here is you've isolated the unknown variable, which in this particular problem is V2. And Francis did that algebraically. So now all you have to do is just plug in your variables. Well, according to what you guys found, P1 is 2.25 atmosphere. V1 is 0.75 liters over P2, which is 1.03 atmospheres. Are there any units of measurement here that cancel out, Max? What?
2.25.
Units of measurement, Max. Atmospheres cancels out. So what will our answer be measured in? What's the only one that's left? Liters. So go ahead and do your math. What do you do first? Order of operations. What do you do first? You do the parentheses. Maybe I don't know if they still teach this in math class, but you guys heard of please excuse my dear Aunt Sally? P means parentheses, E means E means exponents, M means multiplication, then division, then addition, subtraction. You always have to do division first. So I'm going to show my work. 2.25 times 1.03 equals 2.32 liters over 1.03. 2.32 divided by 1.03. Your answer should be approximately, wait, that can't be right. I got that wrong. My bad. 2.25 times 0.75. Yeah, that was my fault. Oops, Monday blues. You got 1.69, right? Okay. My bad. 1.69. 2.25 times 1.03. I got why do I keep doing that? 2.25 times 0.75. I got 1.69.
Yes.
That's your final answer?
I'm not at the final answer yet.
Oh, okay, yeah, you're right.
1.69 divided by 1.03 equals 1.64 liters. Now, let's take, okay, fair question, Arshan. He's saying, do we go to the hundreds place or what? So let's take a look, guys. How many sig figs are in 2.25? How many are in 0.75? Good. How about 1.03? So we have 2 sig figs in one of the numbers, 3 sig figs in the other. So how many sig figs should your answer have? Whichever number has the fewest number of sig figs, that'll be your final answer. So this is 3 sig figs. What would the answer be with the proper number of sig figs? 1.6 liters. Good point. Okay, so you're just rearranging things algebraically. All right, I am going to put your homework up on the screen. If you're watching from home, I'm going to post it on Canvas. It will be due by 11:59 tonight. Yes, Max? Yeah. I've been telling you particularly several times, have a calculator with you every day in this entire semester. You're being a multiple offender.